Space technology, chemical industries, high-performance computing, science and technology, energy transition. AI possesses the encompassing potential to power up the materials and energy sector of the country. AI-driven solutions are used to optimize both renewable and traditional energy systems all over the world. In the renewable energy space, AI assists in the site selection for solar and wind farms by analyzing geographical and climatic data, ensuring that installations are placed in optimal locations. Government agencies are looking into tapping AI to detect issues in the energy grid, to prevent outages, and ensure smooth operations across power plants in the country. These developments illustrate AI's potential to revolutionize the energy landscape in the Philippines.
Thank you, AI Horizon, for giving PAVE project a platform to disseminate our work. So I'm about to present the PAVE project, or the Prototype Automated Visual Survey Equipment. This project was funded by DOST and implemented by UPNCTS together with UPICE and Computer Science Department in collaboration with the DPWH Bureau of Maintenance. So with the expanding road infrastructure in the country, there is a need to innovate on how we maintain our road. One way of innovating is to implement automation of road defects. Why? Maintenance starts with detecting and identifying these defects in pavement management systems. Identification of surface defect is one way to quantify the road condition. This condition of road is used to optimize the budget, resources on the timing of application of appropriate maintenance and rehabilitation techniques. Currently, these defects are being monitored in the national roads manually by our local surveyors, meaning they are walking along the road to take note of these defects, the location, and the measurement. While most of our local government units implement reactive method, they rely on report of our citizen. Because of this data gathering, there is a high potential of being subjective in identifying these defects, as well as identifying the severity of these defects. To understand the factors that contributes this deterioration of the road were also inaccurate. So what you can see right now in your screen is an attempt to correlate the defect with the factors such as temperature and rainfall, which indicates low correlation. Actually, my hypothesis is, depending on the region, we will have different dominant defect. If the region has high temperature, for instance, we have asphalt road, we have lots of rotting. However, for those regions that have high rainfall, we can have a lot of potholes. And we can improve this prediction by improving also on how we collect this data. I believe our data can be improved by predicting the service life of our road, and we're able to promote the prolongment of the life of the roads. Other than that, since they are doing it manually, our local surveyors are exposed to extreme weather conditions and the risk of being involved to accidents. In fact, other countries all have developed this kind of equipment, but why don't we adopt them? Because of the cost of procurement and as well as the cost entailed with the maintenance. So if we need to calibrate the equipment, sometimes we still need to go to the country where it was manufactured or where it was produced in order to be calibrated. And other than that, there are issues on the feet of this developed equipment with our system. So why not we build our own? So this is the inspiration of the Prototype Automated Visual Survey Equipment. We designed this equipment for our engineers, to inspect the condition of our roads and to reduce the subjectivity and safety hazard, and to increase the efficiency and data gathering, unlike the manual methods. Our prototype consists of detachable hardware that can fit pickup trucks, which is the most common model of the car that were being used in road survey. So we designed it attachable, and after that, it will collect the video footage of the road surfaces, and this video footages will be inputted to the software that we have developed, and this software will have or summarize the report. So this is how the hardware looks like. So we have cameras, and then they're directing to the road surface, and then they're collecting video at around 40 to 80 kilometers per hour. And then we're going to input that in the software. And then the software will translate this video into images. And from the images, it will detect the defects. It will group the images with defects and without defects. So with that, it has also a function wherein the road users or the user of this program can correct the identification or the missed defects. So the detection of defects are based on the Department Order 189, series of 2022. So this is how the software looks like. So you can see a box with different colors where the box indicates the type of defect. So here are some examples of good detection. So as you can see here, there is a crack detected. So it was boxed by color red. And here we have scaling and cracks. So here is a small cracks and another crack, longitudinal crack. Here is a sample of bad detection. As you can see, there are no defect, but then there are some it looks like a mark on the road. Here we have detected some cracks, and the others are not detected. So as you can see, there are still some room for improvement in the equipment, and we're open for collaboration for the ongoing works with the development of the program. And this is how the report looks like, where the location of the defects are indicated, and as well as the code of the defects, and what type of defects it is. It has also estimated the measurement or the severity of these defects. We have validated this equipment together with the DPWH BOM, but we only did our own comparison with what was detected and what we can see in the images. So based on our validation, it is around 67 to 75 accurate in terms of detecting and identifying the road defects. So in summary, the Philippines should prioritize expanding road lengths together with the maintenance and pavement management system. And the PAVE project designed and fabricated a prototype that can assist local surveyors in monitoring road defects. There is a need to elevate the technology readiness level of the equipment by improving its accuracy and testing, adapting it to an actual road inspection. That's the end of my presentation. Thank you.